Hey y'all, here's your warm-up. You know what to do. Pause the video and come back to check your answers. Hopefully before you've watched this video, you've done the absolute value exploration that I've uploaded for an assignment for you. I will treat this video as if you have not, but once again, that is a nice way to start so you don't have to memorize rules, you're actually going to discover them. But let's pretend we haven't gone through that, and we will look at what an absolute value graph looks like. So up here in purple, I have written the parent absolute value function, and again that means the most basic function in this whole family of absolute value. And let's start by making a table, and again when you do that you can pick whatever points you want as your domain. If I insert a -2 in for x and take its absolute value, hopefully you remembered from the warm-up slide that it will always turn positive. Even if it starts off positive, it'll stay positive. You need to understand inherently what absolute value means. Now let's graph it. I'm going to graph this part first. 0, 0, 1, 1, and 2, 2. And if I create a line through here, this looks like what we've been doing all chapter long, linear equations. However, the difference comes on the other side. Because when you take an absolute value of a negative number, you're always going to get a positive, it ends up reflecting this side of the graph back up. And it ends up looking like a V. All absolute value functions will look like this. Take a second and to describe in your own words what the absolute value does to the graph. Let's go a step further and figure out what adding or subtracting numbers outside the absolute value does to our graph. I will pick the same input values as before. Substituting in a -2 and taking its absolute value gives me a +2. And 2 minus 4 gives me a -2. Substituting in a -1 and taking its absolute value gives me a +1. 1 minus 4 is a -3. Your table finishes up this way. Plot these points. Again, you see that you have this V shape, but it's moved. Can you describe how it changed compared to what our original parent function was? What words would you use? The official math words we may use are that this whole absolute value graph is shifted down 4. Well, what exactly has shifted down 4? Every point. But there is a special point on this function that we talk about, and that is the tip. That's called a vertex. So we can describe the movement in this graph as the vertex has shifted down 4. We understand that every other point came with it. How do you think our absolute value function or graph will look when we add a number to the outside of it? Let's find out. Picking the same points as I have for the other two tables, I would like you to fill in what your output values are, just to make sure you're doing your absolute value correctly. Pause the video. If you got some of them wrong, make sure that you redo them and figure out what exactly you did do wrong. But for now, let's go ahead and graph the coordinate pairs that we have. Now, how does this graph look compared to the parent function? What would you say about this one? Hopefully you use the vocabulary word that it is shifted up to. Now, what is shifted up to? The vertex. So the vertex is shifted up to, which is very much related to this +2 on the outside of the absolute value. That acts as a y-intercept. And you know how those behave with lines. They behave similarly with absolute values. They will shift your vertex up and down on the y-axis. But what if the number we're adding or subtracting is on the inside of the absolute value? That changes things completely. So let's discover what's happening here. And I'm going to give you your input values on this one because I already know how it's going to behave, and I want to make sure that you see it on your grid. Substituting these numbers inside the absolute value for x, we get -7 plus 5, which is a -2. And the absolute value of a -2 is a +2. -6 plus 5 is a -1. That means the absolute value of -1 is a +1. -5 would get you a 0. -4 would get you a 1. And -3 would get you a 2. Plot these on your coordinate plane. Is that what you thought would happen? How would we talk about that in comparison to the absolute value of x, the parent function? Here's the tricky part. Inside our absolute value symbol, we had a +5, but our graph moved to the left. I think most of us would have thought that it would move to the right. Here's how I can explain that this is happening. When we have an absolute value function, there are these things that we call transformation equations. And we've sort of seen this happen before with the point-slope equation. When the equation or formula comes to us with a minus sign already inside of it, if you see a plus sign show up as we did here, it means that our value for h had to be negative. Here's what really went on in our problem. You know that this minus negative became that positive. And so our horizontal movement, h stands for horizontal, was really -5. That's why it seems to be moving backwards from what we expect. So when we see a plus sign show up, our vertex moves to the left. Can you guess what's going to happen when we have a -2 or an x -2 inside the absolute value? Let's guess. Or experiment. In this case, we want these numbers, so we end up on our graph. Substitute them in and finish off your table. Plot your points. Is this what you thought would happen? Remember, our equation for transformations had a minus sign in it. In this case, our value for h is really a positive 2. Worst case scenario, you need to understand or memorize that when you have a minus value inside that absolute value symbol, that your vertex will move to the right. Hopefully you can start to see that maybe you won't need to make tables for all of these, and that is the ultimate goal. You need to see what these numbers and where they're located does to your absolute value graph. So let's summarize what we've discovered. When we have a number outside of our absolute value, it acts as a y-intercept. Because there's a plus here, we know that our vertex will be shifted up on the y-axis. In the next example, we have minus some number. When we're subtracting a number outside the absolute value symbol, you know your vertex will be shifted down on the y-axis. We explored what happens when we have plus some number, but inside the absolute value symbol. That's the key. It needs to be inside. When it is inside the absolute value and added, our vertex will be shifted to the left. And it's shifted to the left on the x-axis. Finally, we have the situation where we are subtracting a number inside the absolute value symbol, and that means our vertex will be shifted right on the x-axis. So knowing these characteristics will allow you to graph any absolute value equation without making a table. Let's practice. Here are two examples. The first one, I have x minus 3 inside the absolute value symbol. Which way will that move your vertex? It will move your vertex right 3. So if your vertex started here, the x minus 3 inside the absolute value symbol will move your vertex over here to 3 places, so right 3. And then you proceed by drawing the rest of the V, which is your absolute value graph. Let's try it again. I have x, the absolute value of it, minus 6. So your absolute value parent function's vertex will always be here, and then things are happening to it. So in this case, we have the minus 6. That will move it down 6 places on your y-axis. From there, you just continue drawing your V. And remember, it is up 1 over 1, if you're wondering how wide it is.